The 14th anomaly. Nobody saw coming. Something is happening right now that the scientific establishment does not want you to think about too carefully. In the next 48 hours, the most mysterious object ever to enter our solar system will reach its closest point to Earth. And instead of celebrating this moment of cosmic contact, half of the astronomical community is pretending that nothing unusual is happening at all. But here is the problem. The numbers do not lie. And the numbers surrounding 3I Atlas have just revealed a 14th anomaly so statistically improbable that the chance of it occurring naturally sits at 1 in 40,000. Harvard professor Avi Loeb published his findings just 2 days ago, and what he discovered about the alignment of this object's rotation axis changes everything we thought we understood about interstellar visitors. Tonight, we are going to walk through every piece of evidence, every calculation, and every uncomfortable question that mainstream science refuses to ask. By the time we reach the end of this journey, you will understand why December 19th, 2025 might be remembered as one of the most significant dates in human history. Or perhaps it will be remembered as the day we looked directly at something extraordinary and chose to call it ordinary. Let us begin with what we know. On December the 16th, 2025, Avi Loeb released an essay that sent shockwaves through certain corners of the scientific community while being almost entirely ignored by others. The essay detailed what he calls the 14th anomaly of 3I Atlas, and it centers on something deceptively simple. The rotation axis of this interstellar object is aligned to within 8 degrees of the direction of the Sun. Now, if you're not immediately struck by why this matters, let me paint the picture more clearly. Imagine you are throwing a football across a field. The chances of that football spinning in such a way that its axis points almost perfectly at a specific lamppost on the far side of the field are extraordinarily small. Now imagine that football has been travelling through the empty void of interstellar space for billions of years before arriving at that field. The probability of its spin axis aligning with any particular direction by pure chance becomes vanishingly small. Loeb calculated that probability at 0.5%. That means there is a 99.5% chance that this alignment did not happen by accident. But wait, it gets stranger. A new paper published in Astronomy and Astrophysics just days ago reported the detection of a periodic wobble in the anti-tail jet of 3I Atlas. This wobble reveals something remarkable about the object's geometry. The jet base, the point from which material is being ejected toward the Sun, is offset by less than 8 degrees from the poles of the rotation axis. Think about what this means. As the nucleus of 3I Atlas rotates every 16 hours, this jet traces a tight cone around the rotation axis, barely deviating from the sunward direction. For a natural comet, this configuration would be extraordinarily unlikely. The jet would typically spray material in a much wider arc, showing dramatic wobbles as different parts of the surface rotate into and out of sunlight. Instead, 3I Atlas behaves as though it was designed to maintain a stable, consistent output pointed directly at the Sun. And this is where the 14th anomaly takes on an even more unsettling dimension. Before perihelion, when 3I Atlas was approaching the Sun back in July and August, this anti-tail jet was prominent and stable. The object passed its closest point to the Sun on October 29th. Now, basic physics would suggest that the active region producing this jet should have rotated to the night side of the object after perihelion. The Sun is now illuminating what was previously the dark hemisphere. Yet here we are in December, and 3I Atlas is still producing a prominent sunward jet. Loeb points out the implication. For this to happen naturally, there must be a new pocket of ice near the opposite pole that conveniently activated after perihelion, producing an almost identical jet pointing in the same sunward direction. The old jet base, which was active before perihelion, must have gone dormant at exactly the right time. The precision required for this to occur by chance is staggering. The latest images taken on December 15th, 2025 show this anti-tail jet, extending outward for 500,000 kilometers, tightly collimated to within 8 degrees, across that entire distance. 500,000 kilometers. That is greater than the distance from Earth to the Moon. And this beam of material remains focused, coherent, and pointed directly at the Sun. Now, my colleagues who work in the field will tell you there are natural explanations. They will invoke complex models of ice distribution, thermal lag, and unusual surface features. And they may be right. Science demands that we consider all possibilities, but science also demands that we pay attention when the probabilities stack against natural explanations to the point of absurdity. Loeb has calculated that the combined probability of the anti-tail appearing both before and after perihelion, both times aligned with the sunward direction to within 8 degrees, is approximately 0.000025. That is 25 in 1 million, and this calculation does not even factor in the other 13 anomalies that have been documented since July. The retrograde trajectory aligned with the ecliptic plane, the arrival from the direction of the WOW signal, the timing that brought the object close to Mars, Venus and Jupiter while keeping it hidden from Earth at perihelion, the unprecedented nickel-to-iron ratio that resembles industrial alloys, the extreme negative polarization unlike any known comet. Each anomaly on its own might be dismissed as unusual but not impossible. Together, they paint a picture that becomes increasingly difficult to ignore. As of today, December 18th, 3I Atlas sits approximately 268 million kilometers from Earth. Tomorrow, that distance will shrink to its minimum of 269 million kilometers before the object begins its long journey outward, past Jupiter, and eventually back into the interstellar void from which it came. We have perhaps weeks of quality observation time remaining. The data being collected right now by Hubble, by Webb, by XMM Newton, by ground-based observatories around the world, this data will be analysed for years, decades, and the conclusions drawn from that analysis may force us to reconsider everything we believe about our place in the cosmos. But there is something even more troubling about the 14th anomaly that Loeb only hinted at in his essay. Something about the geometry of this object's rotation that suggests an almost engineered level of thermal control. You see, for the anti-tail jet to remain active only when facing the sun, the night side of 3I Atlas must be extraordinarily well insulated. 8 degrees from impossible heat does not simply stop at a boundary. It flows, it conducts, it radiates. On any natural body tumbling through space, warmth absorbed on the sunlit side will gradually migrate through the interior until the entire object reaches some form of thermal equilibrium. This is basic physics, the kind of principle that undergraduate students learn in their first year of planetary science. And yet 3I Atlas appears to be violating this principle in a way that has forced Avi Loeb to document what he now calls a 15th anomaly. Let me explain why this matters so profoundly. For the anti-tail jet of 3I Atlas to function the way we observe it functioning, the ice pockets responsible for producing the jet must remain frozen and dormant when they rotate to the night side. They cannot slowly sublimate from residual heat. They cannot gradually warm as thermal energy conducts through the nucleus. They must switch off almost completely when they leave direct sunlight, and switch back on when they return to the day side. This requires insulation. Exceptional insulation. The kind of insulation that prevents heat from flowing through a body for periods longer than several months. And here is the problem. Natural comets do not possess this characteristic. The rocky, icy, dustite matrix that makes up a typical cometary nucleus allows heat to flow relatively freely. A pocket of ice on the day side will warm its surroundings, and that warmth will eventually reach the night side. 3I Atlas apparently operates by different rules. Dr. Eric Quito and Dr. Frank Lokian, colleagues of Loeb at Harvard, have independently examined this thermal puzzle and reached similar conclusions. For the object to maintain separate, independently activated jet bases at opposite poles, each capable of producing a tightly collimated anti-tail when illuminated by the sun and going completely dormant when not, the internal structure of 3I Atlas must be fundamentally different from any comet we have ever studied. Think about what we are being asked to believe if we accept the natural explanation. First, the rotation axis of 3I Atlas happened to align within 8 degrees of the sunward direction by pure chance. Second, this alignment allowed one pole to remain in constant sunlight during approach, producing the pre-perihelion anti-tail jet. Third, after perihelion, when the geometry shifted and the opposite pole became illuminated, a completely separate ice reservoir happened to exist at almost exactly the opposite position, producing a nearly identical jet. Fourth, the original jet base went dormant at precisely the right time, showing no residual activity from thermal lag. Fifth, both ice reservoirs happened to produce jets collimated to within 8 degrees, across distances exceeding 500,000 kilometres. Each of these requirements represents an independent improbability. Multiplied together, they produce a combined probability so small that Loeb has calculated it at approximately 0.00000000025. That is one chance in 4 billion. Now, I want to be careful here. I am not telling you that 3i Atlas is definitely an artificial object. What I am telling you is that the mathematics of probability are screaming at us, and much of the scientific establishment is covering its ears. The images captured on December 15, 2025 by amateur astronomer Tirasak Thalwang in Rayong, Thailand, show the anti-tail extending toward the lower left of the frame, pointing directly at the sun. Additional processing by astronomer Tony Scarmato on December 9th and 15th reveals the same structure, the same collimation, the same impossible geometry that has persisted for months. What mechanism could produce such consistency? For a natural comet, the answer is essentially nothing. Cometary jets are notoriously chaotic. They sputter and shift. They respond to changes in solar heating with complex, unpredictable behaviors. The famous comet 67P Churyumov-Gerasimenko, studied extensively by the Rosetta mission, displayed jets that wandered across its surface, activated and deactivated seemingly at random, and never maintained anything approaching the geometric precision we observe in 3i Atlas. But there is another possibility that Loeb has raised, carefully and with appropriate scientific caution. A technological spacecraft might have reason to align the outflow from its thrusters in the direction of the sun. Such alignment could serve multiple purposes. It could provide course correction. It could clear a path of micrometeorites ahead of the object. It could even serve as a form of propulsion, using solar radiation pressure in combination with expelled material to fine-tune trajectory. The anti-tail of 3i Atlas does not behave like sublimating ice. It behaves like directed thrust. I can already hear the objections forming in your mind. If this were a spacecraft, would we not see other signs of technology? Would there not be radio emissions, artificial lighting, obvious manufactured structures visible in our telescopes? Perhaps, or perhaps not. Consider that any civilization capable of launching an interstellar probe would likely be millions or even billions of years more advanced than our own. Such a civilization might have learned to disguise its technology within natural-looking structures. It might use propulsion systems that mimic cometary outgassing. It might deliberately avoid the electromagnetic signatures that a primitive species like humanity would recognize as artificial. This is not wild speculation. This is logical inference based on what we know about how civilizations might approach the challenge of interstellar exploration. The astronomer Carl Sagan once noted that any sufficiently advanced technology would be indistinguishable from magic. We might update that observation for our current situation. Any sufficiently advanced spacecraft might be indistinguishable from a comet. But let us return to the hard data, because the data is what matters. The rotation period of 3i Atlas has been measured at 16.16 hours, plus or minus 0.01 hours. This measurement comes from periodic brightness variability observed during July 2025. The precision of this measurement allows us to calculate the centrifugal acceleration at the surface of the nucleus. For a body with a radius of approximately 2 kilometers rotating once every 16 hours, the centrifugal force at the surface is roughly 0.0025 centimeters per second squared. This is tiny, just 2.6 millionths of Earth's surface gravity. The object is rotating slowly enough that anything on its surface would experience almost no outward force. Loeb points out an interesting implication. If you wanted to create artificial gravity similar to what we experience on Earth, you would need to spin 3i Atlas once every 1.5 minutes instead of once every 16 hours. This is not what we observe, but it does tell us something about the object's structural stability. At its current rotation rate, 3i Atlas could maintain complex surface features, directed jets, and asymmetric ice distributions without centrifugal forces tearing them apart. The slow rotation is consistent with either a natural object that has been gradually despun over billions of years, or an artificial object designed to maintain structural integrity during a long interstellar journey. As December 19th approaches, and 3i Atlas reaches perigee, the astronomical community faces a choice. we can continue treating this object as an ordinary comet, filing away the anomalies as statistical flukes and moving on to the next discovery. Or we can acknowledge that the evidence before us demands a more serious investigation. The 8-degree alignment is not just a number, it is a boundary, a threshold. On one side lies the comfortable assumption that everything in the cosmos operates according to principles we already understand. On the other side lies the terrifying and exhilarating possibility that we are witnessing something genuinely new. And as 3I Atlas continues its silent journey through our solar system, the heat distribution within its nucleus holds secrets that might take years to fully comprehend. The night side that should not stay. Cold and natural heat conduction follows predictable rules. Energy flows from hot regions to cold regions until equilibrium is achieved. This principle governs everything from the coffee cooling in your mug to the thermal behavior of asteroids tumbling through the void. And when we apply this principle to 3I Atlas, we encounter a problem that mainstream astronomy has not adequately addressed. The night side of this interstellar visitor should not stay cold. Let me walk you through the physics of what we are observing. 3I Atlas rotates once every 16 hours. This means that any given point on its surface spends approximately 8 hours in sunlight and 8 hours in darkness during each rotation. Over the course of weeks and months, solar energy absorbed during the day should conduct through the nucleus, gradually warming the interior and eventually raising the temperature of the night side. This is exactly what we see with every comet in our solar system. The nucleus of a typical comet acts like a thermal battery, absorbing heat during solar illumination and slowly releasing that heat as the surface rotates into darkness. Ice sublimation continues even on the night side, driven by residual warmth stored within the cometary material. 3I Atlas does not appear to follow this pattern. The jet bases at opposite poles of this object activate only when directly illuminated by the sun. When they rotate to the night side, they go dormant, completely dormant. There is no gradual tapering of activity. There is no residual outgassing from stored thermal energy. The jets simply switch off, as if controlled by some mechanism that responds instantaneously to solar illumination. Avi Loeb has identified this behavior as a 15th anomaly, distinct from but related to the 14th anomaly concerning rotational alignment. For the observed jet behavior to occur naturally, 3I Atlas must possess thermal insulation properties unlike any cometary body ever studied. How unusual would such insulation need to be? Consider that the object has been travelling through our inner solar system for months. It passed within 1.4 astronomical units of the Sun at perihelion, closer than Mars orbits. The solar flux at that distance is intense, more than enough to heat the surface of any rocky or icy body to temperatures that would drive significant sublimation. Yet the night-side regions of 3I Atlas apparently remained cold enough to prevent any ice activation until they rotated back into direct sunlight. The thermal conductivity required to achieve this isolation is extraordinarily low. We are talking about insulation comparable to the most advanced materials humanity has ever produced. Aerogels, vacuum-insulated panels, multi-layer insulation used on spacecraft. Natural cometary materials do not possess these properties. Dr. Frank Lorkien, who has consulted with Loeb on the thermal analysis, suggests that the internal structure of 3I Atlas might be fundamentally different from the porous, homogeneous matrix we expect in a natural comet. The object might contain voids, barriers, or compositional boundaries that prevent heat from flowing between different regions of the nucleus, or it might contain something else entirely. I want to pause here and acknowledge the elephant in the room. Every time we discuss anomalies like this, there is a temptation to leap immediately to the extraterrestrial hypothesis. And every time we do so, mainstream scientists rightfully push back, demanding that we exhaust natural explanations before invoking artificial ones. Fair enough. Let us examine what natural explanations might account for the observed thermal behavior. One possibility is that 3I Atlas formed in an environment radically different from the protoplanetary disk that produced our solar system comets. Perhaps the interstellar medium from which it originated was depleted in certain elements, leading to a composition with unusually low thermal conductivity. Perhaps the billions of years of cosmic ray bombardment it experienced during its interstellar journey altered its surface properties in ways we do not yet understand. Another possibility is that our observations are incomplete. The jets we see might represent only a fraction of the total outgassing activity. There might be diffuse sublimation occurring across the entire surface that our instruments are not sensitive enough to detect. The apparent on-off behaviour of the polar jets might be an artefact of observational limitations, rather than a true reflection of the object's thermal dynamics. These are reasonable hypotheses. They deserve investigation, but they also face significant challenges. The spectroscopic observations of 3I Atlas have been extensive. Multiple telescopes, including Hubble, Webb, and numerous ground-based facilities, have characterized the gas and dust emissions from this object in extraordinary detail. If there were significant diffuse sublimation occurring on the night side, we would expect to see evidence of it in the spectral signatures. We do not. The composition of 3I Atlas, while unusual, does not suggest materials with anomalously low thermal conductivity. The detected gases include carbon dioxide, carbon monoxide, water vapour, hydrogen cyanide, and methanol. The dust appears to contain silicates and organic compounds. These are not exotic materials that would naturally form insulating barriers. Which brings us back to the uncomfortable question. If natural explanations struggle to account for the observed thermal behaviour, what alternatives remain? Loeb has suggested, with appropriate caution, that an artificial structure might explain the anomalies. A spacecraft designed for interstellar travel would need exceptional thermal management capabilities. It would need to survive the cold of the interstellar medium, temperatures approaching absolute zero, for millions or billions of years. It would then need to survive the heat of close solar approach without catastrophic damage to sensitive systems. Such a spacecraft might be constructed with internal compartmentalization, thermal barriers between different sections, and active or passive cooling systems that prevent heat from propagating through the structure. From the outside, these engineering features might produce exactly the kind of on-off jet behavior we observe in 3I Atlas. The anti-tail jets might not be sublimating ice at all. They might be deliberate expulsions of material, controlled by systems that respond to solar illumination as a power source or triggering mechanism. I recognise how extraordinary this suggestion sounds. I also recognise that extraordinary claims require extraordinary evidence. But I would argue that the evidence we have accumulated over the past 5 months is itself extraordinary. The statistical improbability of the observed anomalies taken together exceeds anything we have encountered in the study of small solar system bodies. And tomorrow, 3I Atlas reaches its closest approach to Earth. At 269 million kilometres, it will still be far beyond the reach of any spacecraft we could conceivably launch. We will not be sending probes to investigate. We will not be collecting samples. We will have only the light that reaches our telescopes, photons that have travelled 15 minutes across the void to tell us stories about an object that refuses to behave like anything we have seen before. The night side of 3I Atlas holds secrets we may never fully unravel, but the questions it raises will persist long after the object fades from our instruments and continues its journey toward the outer solar system. Some scientists argue that we should simply accept 3I Atlas as an unusual comet and move on. After all, with a sample size of only 3 interstellar objects ever detected, our expectations about what such objects should look like are necessarily limited. Perhaps they are all this strange. Perhaps the anomalies will become normal once we have observed a dozen or 100 interstellar visitors. Perhaps. But there is another possibility that keeps certain researchers awake at night. The possibility that 3I Atlas is strange precisely because it is not natural. That we are witnessing technology so advanced it can mimic cometary behaviour while pursuing objectives we cannot begin to comprehend. As the sun illuminates first one pole and then the other, as jets activate and deactivate with mechanical precision, the cold darkness of the night side waits in silence. And something within that darkness knows exactly what it is doing. Tomorrow we say goodbye at 269 million kilometres. There is something profoundly melancholic about watching a mystery recede into the darkness. Tomorrow, December the 19th, 2025, 3I Atlas reaches perigee, its closest approach to Earth, at a distance of approximately 269 million kilometres. After that moment, every hour that passes will carry this interstellar visitor farther from our world, farther from our telescopes, farther from our ability to study its secrets. We are running out of time. the Virtual Telescope project has announced a live stream beginning at 11 p.m. Eastern Standard Time tonight, 4 a.m. Universal Time on December 19th. Weather permitting, astronomers and amateur observers around the world will watch in real time as 3i Atlas makes its closest pass. For those with telescopes of 8 inches or larger under dark skies, there is a chance to see it yourself. A faint smudge of light in the constellation Leo that carries with it questions humanity may never answer. 269 million kilometres. Let me put that distance in perspective. It is roughly 1.8 astronomical units, nearly twice the distance from Earth to the Sun. It is more than 700 times farther than the Moon. In terms of human experience, it is an utterly unreachable expanse, a gulf so vast that the fastest spacecraft ever built would take years to cross it. Light itself requires 15 minutes to make the journey, and yet, in cosmic terms, this is remarkably close. 3i Atlas passed within 29 million kilometres of Mars in early October. It came within 54 million kilometres of Jupiter's orbital path. Its trajectory brought it inside the orbit of Venus. For an object born around a distant star, wandering through the galaxy for billions of years, arriving at our solar system and threading through the inner planets with such precision, is either an extraordinary coincidence or something else entirely. NASA has emphasized repeatedly that 3i Atlas poses no danger to Earth. This is true. At nearly twice the Earth-Sun distance, there is no possibility of collision, no gravitational perturbation that would affect our planet, no debris that would reach our atmosphere. We are safe. But safety is not the same as significance. The European Space Agency has deployed its XMM Newton X-ray Observatory to study 3i Atlas. For 20 hours on December the 3rd, the spacecraft trained its sensitive instruments on the interstellar visitor, capturing the glow of X-rays produced when gases streaming from the comet collide with the solar wind. These observations complement data from the James Webb Space Telescope, from Hubble, from ground-based observatories on every continent. Never in human history have we marshalled so many instruments to study a single small body passing through our cosmic neighbourhood, and never have those instruments returned data so consistently puzzling. The X-ray images reveal 3i Atlas glowing in low-energy radiation, the telltale signature of charge exchange between solar wind particles and cometary gases. This is expected behaviour for any active comet. What is less expected is the intensity and distribution of that glow, suggesting outgassing rates and compositions that continue to surprise researchers. ESA scientists have noted that X-ray observations are uniquely sensitive to gases like molecular hydrogen and nitrogen, species that are nearly invisible to optical and ultraviolet instruments. The hope is that these observations will help determine whether 3i Atlas contains exotic ices similar to those hypothesized for the first interstellar object, 1i Oumuamua. If nitrogen or hydrogen ice is present, it would suggest formation conditions radically different from anything in our solar system. But the clock is ticking. After perigee, 3i Atlas will begin its long journey outward. By late January 2026, it will have faded significantly, requiring larger telescopes and longer exposures to detect. By spring, only the most powerful observatories will be able to track it. By summer, it will be a memory, a data set to be analysed for decades but never supplemented with new observations. The International Asteroid Warning Network has recognised the urgency. They have launched a planetary defence campaign running from November 27, 2025 through January 27, 2026, coordinating observations from over 230 facilities worldwide. This is the largest coordinated observation campaign ever conducted for an interstellar object. And yet, for all our instruments, for all our coordination, we cannot answer the fundamental question: what is 3i Atlas? NASA officials, at their press conference on November 19th, stated definitively that the object is a comet. Natural, ordinary, nothing to see here. Associate Administrator Amit Kshatriya reassured the public that there is no connection to extraterrestrial life, dismissing the speculation that had spread across social media. But reassurance is not explanation, and the anomalies remain unexplained. Consider what we know about the trajectory of 3i Atlas. It entered our solar system on a retrograde path moving opposite to the direction of planetary motion, aligned within 5 degrees of the ecliptic plane. The probability of this alignment occurring by chance is roughly 0.2%. Its arrival timing was fine-tuned to bring it close to Mars, Venus and Jupiter, while keeping it hidden behind the Sun at perihelion, invisible to Earth-based observers during its closest solar approach. The probability of this timing occurring by chance is roughly 0.005%. These are not wild speculations. These are calculations based on orbital mechanics, published by researchers at Harvard and elsewhere, available for anyone with a mathematical background to verify. And now, as we approach perigee, 3I Atlas continues to display its impossible anti-tail, its anomalous composition, its inexplicable thermal behavior. It has given us 15 documented anomalies and counting. Each one might be explained away individually. Together they form a pattern that demands attention. Tomorrow we say goodbye. Not forever, perhaps. 3I Atlas will remain detectable for months, visible in our instruments as it crosses the orbit of Jupiter and continues outward. But the quality of our observations will degrade. The details will blur. The opportunity to capture high-resolution spectroscopy, to measure subtle variations in brightness, to detect faint features in the coma and tail, this opportunity is closing. In March 2026, 3I Atlas will reach its closest approach to Jupiter, passing within approximately 53.5 million kilometers of the gas giant. This distance is remarkable because it almost exactly matches Jupiter's Hill radius, the boundary at which Jupiter's gravitational influence dominates over the Sun's. Loeb has calculated that the non-gravitational acceleration displayed by 3I Atlas near perihelion nudged its trajectory by exactly the amount needed to achieve this match. Coincidence? Perhaps. But if you have been following this documentary, you know how many coincidences have accumulated around this object. Some researchers have speculated that 3I Atlas might release something as it passes Jupiter. Technological devices, probes, satellites designed to orbit the gas giant at its Lagrange points, locations where gravitational forces balance and orbital corrections are minimal. This is science fiction territory, and I present it as such. But it is science fiction grounded in the mathematics of what we observe. The Juno spacecraft currently orbiting Jupiter will be watching. If new objects appear in Jovian space after the passage of 3I Atlas, objects that we did not put there, we will know. Until then, we watch. We record, we analyze, and tomorrow at the moment of closest approach, we pause to acknowledge what 3I Atlas represents. It is a messenger from another star system, carrying information about conditions and processes we have never directly observed. Whether that messenger is natural or artificial, whether it carries intent or merely momentum, it has reminded us that the universe is vast beyond comprehension and filled with surprises we have only begun to imagine. 269 million kilometers, close enough to study, too far to touch. Receding into the darkness with every passing hour, the farewell has begun. When a comet turns green, something changed. Inside colour tells stories that spectra alone cannot fully capture. When astronomers at the Gemini North Telescope in Hawaii released new images of 3I Atlas on December the 12th, 2025, those images revealed something that had changed since the object's first detailed portraits back in August and September. The interstellar visitor had turned green. This is not a subtle shift. The earlier images from Gemini South in Chile showed 3I Atlas glowing with a distinctly reddish hue, the signature of organic compounds called tholins dusting its surface. Now, 4 weeks after perihelion, the coma surrounding the nucleus displays a faint but unmistakable greenish glow that was simply not present before. Something inside 3I Atlas has changed. The green colour in cometary comas typically comes from diatomic carbon, molecules consisting of two carbon atoms bound together. When excited by solar radiation, these molecules emit light at green wavelengths, producing the characteristic verdant glow seen in many solar system comets. The famous comet 12 P. Pons Brooks, which passed through our skies in 2024, displayed this green coloration prominently. So did Comet C 2025 F2 Swan just this year. But here is what makes 3I Atlas different. Early observations suggested that this interstellar comet was unusually low in diatomic carbon. Pre-perihelion spectroscopy detected abundant carbon dioxide, carbon monoxide, hydrogen cyanide, and methanol, but relatively little of the C2 molecule that produces green emission. This was one of the factors that made 3I Atlas compositionally distinct from solar system comets. Now that C2 is appearing, where did it come from? Diatomic carbon does not typically exist in cometary ice. It forms in the coma itself, assembled from free-floating carbon atoms that are released when other carbon-containing molecules break apart under solar radiation. The process is dynamic, with C2 being created and destroyed rapidly as solar ultraviolet light both forms and photodissociates the molecule. For 3I Atlas to develop significant C2 emission only, after perihelion suggests that something about its outgassing changed as it rounded the Sun. Either new reservoirs of carbon-bearing material became accessible, or the chemistry of the coma shifted in ways that favour C2 production. Both possibilities point to thermal evolution occurring deep within the nucleus. The Gemini North images were captured on November 26, 2025 as part of a public engagement initiative called Shadow the Scientists. Students from Chile and Hawaii joined astronomers via video link, watching in real time as the telescope collected data on one of the most mysterious objects ever to visit our solar system. What those students witnessed was history being made. The images combine exposures through 4 filters: blue, green, orange, and red. The composite reveals the coma's current state with stunning clarity. Background stars appear as colourful streaks, their positions shifting relative to the comet as the telescope tracked the moving target. And there, at the centre of the frame, 3I Atlas glows with its new green tint, fundamentally different from how it appeared just months ago. Bryce Bolin, the researcher leading these observations, noted that many comets exhibit delayed reactions to solar heating. The time required for heat to propagate through a cometary nucleus can be substantial, meaning that changes triggered at perihelion might only become visible weeks or months later. We may be witnessing exactly such a delayed response in 3I Atlas. But delay alone does not explain the complete transformation in colour. The shift from red to green implies a fundamental change in which molecules dominate the visible emission from the coma. It suggests that layers or pockets of material that were previously sealed away have now been exposed to sunlight, releasing their contents into space. What else might be released as 3I Atlas continues to heat internally? This question takes on additional significance when we consider the anomalous nickel signatures detected earlier in the object's passage. Spectroscopic observations revealed far more nickel than iron in the gas plume, a ratio that resembles industrially produced nickel alloys, rather than the roughly equal abundances found in most natural comets. Combined with extreme levels of hydrogen cyanide and a nickel to cyanide ratio orders of magnitude higher than any known comet, including 2I Borisov, the composition of 3I Atlas remains deeply puzzling. Some researchers have proposed that 3I Atlas might be running low on ice, transitioning from an active comet into a dormant asteroid-like body. Under this hypothesis, the changing colours and outgassing patterns reflect the final exhaustion of volatile reservoirs, the last gasps of a comet that has spent billions of years slowly evaporating as it wandered through interstellar space. Others have suggested that the object might be a metal-rich body covered in cryovolcanoes, vents that periodically erupt as internal pressure builds and releases. This model could explain the directed jets, the unusual composition, and the thermal behaviour that seems so unlike typical cometary activity. And then there is the possibility that neither natural model adequately captures what 3I Atlas actually is. The colour change from red to green might have nothing to do with conventional cometary chemistry. An artificial object designed to harvest solar energy might display different thermal signatures as it adjusts to varying conditions. Systems that were dormant during interstellar cruise might activate as power becomes available. Processes that we interpret as sublimation might actually be something else entirely, perhaps waste heat disposal, propellant management, or activities we lack the conceptual framework to recognise. I want to emphasise that this is speculation. The scientific data supports a natural interpretation, and most astronomers accept that 3I Atlas is simply an unusual comet. But speculation has its place in science, particularly when the data itself is unusual enough to warrant expanded thinking. What remains unknown is how 3I Atlas will behave as it continues to cool during its outward journey. Many comets experience outbursts well after perihelion, sudden increases in activity triggered by internal processes that we do not fully understand. The delayed heating that is now producing green emission might eventually trigger more dramatic events. The Gemini Observatory has committed to continued monitoring as the object recedes. Future observations will track changes in gas composition, brightness, and structure, building a complete timeline of how 3I Atlas evolves after its close solar encounter. In the meantime, the green glow serves as a reminder that this interstellar visitor is not static. It is changing, responding, adapting to conditions in our solar system. Whether those responses are purely chemical and physical, or whether they reflect something more purposeful, remains one of the central mysteries of our time. The reddish comet that arrived in July is not the same object that passes closest to Earth today. Something within has transformed, and as we continue to watch, we must remain open to the possibility that more transformations are yet to come. The green light shining from 269 million kilometers away carries information we are still learning to decode. Every photon that reaches our telescopes is a data point, a clue, a fragment of a story that began billions of years ago around a star we may never identify, and the story is still being written. The X-ray portrait from another universe. When the European Space Agency released its X-ray image of 3I Atlas on December 12, 2025, humanity saw something that had never been seen before, an interstellar comet glowing in high-energy radiation, captured by one of the most sensitive X-ray telescopes ever built. The image itself appears almost abstract, a bright red spot at the center, like a fiery beacon against the darkness of space, faint gradients of purple and blue spreading outward, marking the boundary between the comet's influence and the empty void. A thin horizontal line cutting through the frame, an artifact of the detector gap in XMM Newton's European photon imaging camera. But within that abstract beauty lies scientific data of extraordinary importance. XMM Newton observed 3I Atlas for approximately 20 hours on December 3, 2025. During that time, the comet was between 282 and 285 million kilometers from the spacecraft, roughly twice the distance from Earth to the Sun. The observation used the EPIC PN camera, the most sensitive X-ray detector aboard the observatory, capable of registering individual photons across a range of energies. The resulting image shows 3I Atlas glowing in soft X-rays, radiation with wavelengths far shorter than visible light, but longer than the hard X-rays used in medical imaging. This emission was expected. Astronomers have understood for decades that comets can produce X-rays through a process called charge exchange, in which ions in the solar wind collide with neutral gas molecules streaming from the comet and capture electrons in excited states. As those electrons cascade down to lower energy levels, they emit X-ray photons. What makes this observation significant is not the mechanism but the target. This is the first time an interstellar comet has been imaged in X-rays. The data will allow researchers to probe aspects of 3I Atlas that are invisible to optical and ultraviolet instruments. Consider what X-ray observations can reveal. The solar wind charge exchange process is sensitive to the specific gases present in the cometary coma. Different molecules produce different X-ray signatures when they interact with solar wind ions. Water vapor, carbon dioxide, carbon monoxide all leave their mark on the X-ray spectrum. But X-ray observations are uniquely sensitive to species that other wavelengths struggle to detect, particularly molecular hydrogen and nitrogen. This matters because one of the leading hypotheses about the first interstellar object, 1I Oumuamua, involved exotic ices. Some researchers proposed that Oumuamua might have been a chunk of nitrogen ice, or even hydrogen ice, ejected from a distant planetary system and slowly evaporating as it passed through our solar neighborhood. Such exotic ices would produce distinctive X-ray signatures when interacting with the solar wind. Oumuamua is long gone, too distant now for any telescope to observe, but 3I Atlas is still here, at least for a few more weeks. If it contains nitrogen or hydrogen ice, the X-ray data from XMM Newton might reveal it. The image released by ESA shows the comet's X-ray glow extending outward from the nucleus, tracing the coma of gas that surrounds the solid body. The red colouring in the processed image represents low-energy X-rays, the wavelengths most abundant in the observation. The blue background marks regions with few X-ray photons, the empty space through which 3I Atlas travels. Japan's XRISM mission has also observed the comet, detecting a faint extended X-ray halo that may reveal details about how the solar wind interacts with interstellar cometary material. The combination of data from multiple X-ray observatories will provide the most complete picture yet of the high-energy environment around 3I Atlas. But there is another dimension to these observations that deserves attention. X-ray emission requires energy. In the case of cometary charge exchange, that energy comes from the solar wind, the stream of charged particles constantly flowing outward from the sun. The intensity of X-ray emission depends on several factors, including the outgassing rate of the comet, the density of the solar wind at the comet's location, and the composition of the cometary gases. 3I Atlas is producing enough X-rays to be clearly detected by XMM Newton from a distance of nearly 300 million kilometers. This tells us that its outgassing rate is substantial, that the coma is dense with molecules capable of charge exchange, that the comet is actively interacting with its environment in ways we can measure and analyze. But what if the X-rays are not entirely from charge exchange? This is admittedly speculative territory, but it deserves mention given the other anomalies we have discussed. An artificial object operating in the solar system might produce X-ray emissions from sources other than cometary outgassing. Thruster exhaust interacting with the solar wind, waste heat from internal power systems, deliberate signals at wavelengths chosen to be detectable above the background. I present this not as a claim but as a question. The X-ray data from 3I Atlas will be analysed extensively in the coming months. If there are spectral features that do not match natural charge exchange processes, they will be found. And if they are not found, if the X-ray emission proves entirely consistent with natural cometary activity, that too will be informative. Science proceeds by testing hypotheses against data. The X-ray portrait of 3I Atlas provides data that can test hypotheses about this object's nature. Whatever conclusions emerge will be grounded in observation rather than speculation. For now, what we can say with confidence is that 3I Atlas looks like a comet in X-ray light. It produces the soft X-ray glow expected from a body actively outgassing as it travels through the solar wind. This is consistent with its behavior at other wavelengths, with the optical observations showing a coma and jets, with the infrared observations revealing carbon dioxide and water ice. And yet consistency is not proof. A sufficiently sophisticated artificial object might be designed to mimic cometary behavior across the electromagnetic spectrum. It might produce outgassing that generates X-rays through charge exchange while simultaneously performing other functions invisible to our instruments. The perfect disguise would be indistinguishable from the genuine article. We may never know with certainty what 3I Atlas is, but the X-ray portrait adds another piece to the puzzle, another constraint on the possible interpretations, another data point in humanity's first extended observation of an interstellar visitor. The fiery red glow captured by XMM Newton has travelled for 15 minutes to reach us. Photons born in collisions between solar particles and alien gas, carrying information about conditions in a coma that formed from material originating around another star. Whatever else it may be, 3I Atlas is a bridge between solar systems. The X-ray light it produces connects our sun's influence to an object shaped by forces we have never directly observed. And in that connection lies the beginning of a new kind of astronomy, one focused not on the bodies bound to our star, but on the travellers that wander between stars. The portrait from another universe hangs in our data archives now, waiting for the scientists who will spend years extracting its secrets. And somewhere beyond the X-ray glow, the nucleus of 3I Atlas continues its silent journey, carrying whatever truths it holds into the darkness ahead. 53 million kilometers from Jupiter and not 1 meter more. In the mathematics of celestial mechanics, certain numbers carry profound significance. The Hill radius defines the boundary of a planet's gravitational dominance, the sphere within which that planet's gravity overcomes the influence of the Sun. For Jupiter, the largest planet in our solar system, this boundary sits at approximately 53.5 million kilometers from the planet's center. 3I Atlas is heading directly for that boundary, and the precision of its trajectory has become one of the most unsettling aspects of this entire encounter. According to calculations from NASA's Jet Propulsion Laboratory Horizon system, using orbital data collected from over 230 observatories worldwide, 3I Atlas will reach its closest approach to Jupiter on March 16, 2026. The forecasted distance at that moment is 53.445 million kilometers, plus or minus approximately 60,000 kilometers. Read that again. The predicted closest approach distance matches Jupiter's Hill radius to within 1 standard deviation. The margin of error is roughly 1 part in 1,000 relative to the Hill radius itself, or 1 part in 26,000 relative to the full diameter of Jupiter's orbit. This is not a coincidence that can be easily dismissed. Avi Loeb has documented this alignment as one of the most statistically improbable features of 3I Atlas. The probability of a randomly incoming interstellar object arriving at exactly Jupiter's Hill radius is vanishingly small. Yet here we are, watching an object whose trajectory appears fine-tuned to deliver it precisely to the edge of Jupiter's gravitational sphere of influence. But the story becomes even stranger when we examine how this precision was achieved. 3I Atlas did not arrive in our solar system on a trajectory that would naturally bring it to Jupiter's Hill radius. The original orbital calculations, based on observations from July through September 2025, predicted a closest approach to Jupiter that would miss the Hill radius by a significant margin. Then came perihelion. As 3I Atlas rounded the Sun in late October, it displayed non-gravitational acceleration. This is acceleration that cannot be explained by gravity alone, typically attributed to outgassing forces as cometary jets push against the nucleus. The measured acceleration was approximately 5 times 10 to the negative 7th astronomical units per day squared. This tiny acceleration, applied near the point of closest solar approach, nudged the trajectory of 3I Atlas by exactly the amount needed to bring its Jupiter closest approach into alignment with the Hill radius. Let me be explicit about what the mathematics implies. Without the non-gravitational acceleration, 3I Atlas would have missed the edge of Jupiter's gravitational sphere. With the acceleration, it arrives precisely at that boundary. The course correction required to achieve this match was provided by the observed jet activity near perihelion. Coincidence? Possibly. But Loeb has calculated the probability of this specific outcome occurring by chance at approximately 0.004%, or 1 in 25,000. Why would the Hill radius matter? For any object intending to interact with Jupiter's gravitational environment, the Hill radius represents the gateway. Inside this boundary, Jupiter's gravity dominates. Objects that enter the Hill sphere can be captured into orbit, can park themselves at the Lagrange points where gravitational forces balance, or can release smaller objects that will remain bound to Jupiter. The Lagrange points are particularly interesting. L1 and L2 sit along the line connecting Jupiter to the Sun at the Hill radius distance. These are locations where a spacecraft could maintain position with minimal fuel expenditure, ideal spots for observation platforms or relay stations. Our own space programs have placed satellites at the Sun-Earth Lagrange points for exactly these reasons. If 3I Atlas were designed to deploy technological devices in the Jovian system, arriving at the Hill radius would make strategic sense. The timing and trajectory would allow the release of objects that could spiral inward to the Lagrange points or other stable configurations within Jupiter's gravitational influence. I want to emphasize that this is hypothesis, not established fact. We have no direct evidence that 3I Atlas will release anything as it passes Jupiter. We have no images showing technological devices separating from the nucleus. What we have is a trajectory that appears engineered to arrive at a gravitationally significant boundary, achieved through acceleration that occurred at the optimal time for orbital modification. The Juno spacecraft, currently orbiting Jupiter, will be in position to observe during the March 2026 encounter. If new objects appear in Jovian space after the passage of 3I Atlas, Juno's instruments might detect them. The scientific community will be watching closely. There is another aspect to the Jupiter encounter that deserves consideration. Jupiter's immense gravity can significantly perturb the trajectories of passing objects. For 3I Atlas, the gravitational influence of the gas giant will alter its future path through interstellar space. the direction it departs our solar system will be different than it would have been without the Jupiter encounter. Some researchers have proposed that 3i Atlas might experience a course-altering interaction with Jupiter, not just a passive flyby but a gravitational assist that redirects it toward a new destination. The non-gravitational acceleration observed near perihelion is still uncertain in its precise magnitude and direction. If that acceleration was carefully calibrated, the resulting trajectory through the Jupiter encounter could produce almost any desired exit vector. This is how interplanetary spacecraft work. NASA's Voyager probes used gravity assists from Jupiter and Saturn to reach their current positions in interstellar space. A sufficiently advanced mission architecture could use similar principles on scales we can barely imagine. The departure direction of 3i Atlas is predicted to lie toward the constellation Gemini. Where it goes after leaving our solar system, what star or stellar association lies along its path, these questions cannot be answered with current data. But if 3i Atlas is technological in origin, its designers presumably knew exactly where they wanted it to go. Or perhaps more intriguingly, where they wanted it to return. We sometimes assume that interstellar visitors are one-way travelers, objects ejected from distant systems that will never return to their origins. But the universe operates on timescales that dwarf human comprehension. A probe launched 1 billion years ago might be designed to complete a circuit, visiting multiple stellar systems before eventually returning home to report its findings. 3i Atlas could be outbound, or it could be inbound, arriving at our solar system as a waypoint on a journey that began and will end somewhere else entirely. The Jupiter encounter in March will provide more data. Careful tracking of 3i Atlas as it passes through the gas giant's gravitational field will refine our understanding of its trajectory and any non-gravitational forces still acting on it. Observations of the Jovian environment before and after the encounter will reveal whether anything has changed. Until then, we are left with the mathematics. 3.5 million kilometers is the hill radius. 53.445 million kilometers is the predicted closest approach. The difference is a rounding error in cosmic terms, and somewhere in the darkness between here and Jupiter, an interstellar object continues on a trajectory that seems almost impossible to explain by chance alone. The precision is either the most remarkable coincidence in the history of astronomy, or evidence that something far more intentional is at work. The Loeb scale, and the probability of 1. In 4 billion numbers have a way of accumulating until they become impossible to ignore. 1 anomaly might be a fluke, 2 could be coincidence, 3 begins to look like a pattern. But when you reach 15 documented anomalies, each with its own calculated probability of occurring by chance, the mathematics transforms from curiosity into confrontation. Avi Loeb has developed what he calls the Loeb classification scale for interstellar objects, a framework for assessing the likelihood that any given visitor from beyond our solar system might be technological rather than natural. The scale runs from 0, indicating a definitively natural object, to 10, indicating confirmed artificial origin. Most known asteroids and comets sit at 0 or 1. 3i Atlas, by Loeb's assessment, has climbed significantly higher, but the scale itself is less important than the mathematics underlying it. Let us walk through the anomalies in ascending order of probability, from the most improbable to the merely unlikely. The forecasted Jupiter encounter at the hill radius has a probability of roughly 0.004%. The arrival timing that brought 3i Atlas close to Mars, Venus and Jupiter, while hiding it from Earth at perihelion, has a probability of approximately 0.005%. The nucleus mass, orders of magnitude greater than previous interstellar objects while moving faster than both, represents a probability below 0.1%, given our understanding of interstellar debris populations. The retrograde trajectory aligned within 5 degrees of the ecliptic plane has a probability of 0.2%. The arrival direction coinciding with the WOW signal to within 9 degrees has a probability of 0.6%. The extreme negative polarization, unprecedented among thousands of known comets, sits below 1% probability. The 14th anomaly, the alignment of the rotation axis within 8 degrees of the sunward direction, has a probability of 0.5%. The 15th anomaly, the the thermal insulation required for night-side jets to remain dormant, adds another layer of improbability that compounds the 14th. And then there are the compositional anomalies, the gas plume containing far more nickel than iron, resembling industrial alloys. The nickel to cyanide ratio orders of magnitude higher than any known comet, including 2I Borisov. The unusual progression of carbon dioxide, hydrogen cyanide, and methanol emissions during approach. When you multiply independent probabilities together, the combined result shrinks with devastating speed. Take just the first few anomalies, 0.004% times 0.005% times 0.2% times 0.5%. The calculator quickly reaches numbers so small they strain comprehension. 1 in 4 billion. That is the order of magnitude Loeb estimates for certain combinations of the observed anomalies occurring together by chance. Not all anomalies are independent, and careful statistical analysis is required to avoid double counting. But even conservative estimates yield combined probabilities that are difficult to reconcile with the natural comet hypothesis. Critics rightfully point out that we have only observed 3 interstellar objects, far too small a sample to make confident statements about what such objects should look like. Perhaps they are all this strange. Perhaps the anomalies will become routine once we have detected dozens or hundreds of interstellar visitors. This criticism has merit. Our expectations are necessarily calibrated by experience, and our experience with interstellar objects is extremely limited. The first such object, 1I Oumuamua, was itself deeply anomalous, displaying non-gravitational acceleration without any visible coma or outgassing. The second, 2I Borisov, looked more like a conventional comet, but still showed compositional differences from solar system objects. Perhaps interstellar space selects for unusual properties. Perhaps the ejection processes that launch objects between stars favour certain characteristics we have not yet modelled. Perhaps we are simply too ignorant to recognise normal interstellar behaviour when we see it. These are reasonable scientific positions. They counsel caution against premature conclusions. They remind us that the universe is under no obligation to match our expectations, and yet, the anomalies of 3I Atlas are not random unusual properties. They cluster around specific behaviours that would make sense for a technological object. The trajectory alignment facilitates planetary observation. The timing minimises detection at the most vulnerable period. The thermal control enables directed thrust. The Jupiter approach targets a gravitationally significant boundary. If you were designing a probe to survey an inhabited solar system, you might choose exactly these characteristics. You would approach along the planetary plane to maximize observation opportunities. You would time your perihelion to avoid prolonged observation from the third planet. You would maintain thermal compartmentalization to enable controlled propulsion. You would target the largest planet's Hill radius for potential deployment operations. This does not prove that 3I Atlas is artificial, but it does mean the anomalies are not merely unusual in the statistical sense. They are unusual in a way that points toward a coherent interpretation, an interpretation that mainstream science is reluctant to consider. Loeb has been criticised for publicising these calculations, for giving oxygen to extraterrestrial hypotheses that most scientists consider unfounded. His colleagues at Harvard and elsewhere have pushed back, arguing that the anomalies can be explained by natural processes we do not yet fully understand. But Loeb's response is worth considering. Science progresses by recognizing anomalies and taking them seriously. The history of physics is filled with examples where strange observations, initially dismissed as errors or flukes, eventually led to revolutionary discoveries. The precession of Mercury's orbit pointed toward general relativity. The ultraviolet catastrophe in black-body radiation pointed toward quantum mechanics. Anomalies are not problems to be explained away, but opportunities to learn something new. The probability of 1 in 4 billion is not a conclusion. It is a provocation. It says to the scientific community, look at this. Pay attention. Do not dismiss these observations simply because their implications are uncomfortable. 3I Atlas will eventually fade from our instruments, becoming too distant and too faint to observe in detail. The data we collect now, in these final weeks of good visibility, will be all we ever have. If we fail to take that data seriously, if we file away the anomalies under ordinary cometary behaviour without rigorous analysis, we may miss the most significant discovery in human history. or we may simply miss the opportunity to better understand interstellar objects, which would itself be a scientific loss, even if 3i Atlas proves to be entirely natural. The Loeb scale is not meant to declare 3i Atlas artificial. It is meant to quantify our uncertainty, to provide a framework for updating our beliefs as new evidence arrives. The scale for 3i Atlas sits significantly above 1i Oumuamua and 2i Borisov, reflecting the greater number and severity of documented anomalies. Where it will land after the Jupiter encounter, after years of detailed data analysis, remains to be seen. For now, the mathematics speaks clearly. The probability that all observed anomalies occurred by chance is small enough to demand explanation. Whether that explanation is natural or artificial, we owe it to ourselves to find out. 1 in 4 billion are not odds that should let us sleep easily. The scientist who refused to see what the math is. Screaming science is supposed to follow evidence wherever it leads. That is the founding principle, the sacred commitment that separates empirical inquiry from dogma. Yet when the evidence points toward uncomfortable conclusions, even scientists can avert their eyes. And in the case of 3i Atlas, some of the most prominent voices in astronomy have done exactly that. Professor Brian Cox, the celebrated physicist and science communicator, has been perhaps the most vocal critic of extraterrestrial interpretations. In October, shortly after 3i Atlas reached perihelion, Cox posted on social media what he called a response to recent drivel online. His verdict was unequivocal. 3i Atlas is a comet, made of carbon dioxide and water ices and bits of other stuff. It is entirely natural in origin. In a December appearance on the Star Talk podcast with Neil deGrasse Tyson, Cox elaborated on his position. He described the object as potentially 7.5 billion years old, formed before Earth and the Sun from clouds of dust, a message from a dead world that has been wandering the galaxy ever since. He called it illogical to believe that 3i Atlas could be a spacecraft, branding such hypotheses as unfounded. Cox's credentials are impressive. He's a professor of particle physics at the University of Manchester, a fellow of the Royal Society, and one of the most recognisable science communicators in the world. When he speaks, millions listen, and he has spoken clearly. 3i Atlas is not alien technology, but here is the problem. Cox has not addressed the anomalies. In none of his public statements has Cox engaged with the mathematical calculations that Loeb has published. He has not explained how the rotation axis alignment occurs naturally with a probability of 0.5%. He has not addressed the thermal insulation requirements for night-side jet dormancy. He has not discussed the Jupiter-Hill radius coincidence or the trajectory alignment with the ecliptic plane. He has simply declared the object natural and moved on. This is not how science is supposed to work. A hypothesis should be tested against evidence, not asserted based on intuition or professional consensus. Cox may well be correct that 3i Atlas is a comet, but declaring that conclusion without addressing the specific observations that challenge it is an argument from authority, not an argument from data. Penn State astrophysicist Jason Wright has offered a more substantive critique. In a detailed blog post, Wright systematically addressed several of Loeb's claimed anomalies, arguing that they represent expected behaviour for interstellar comets rather than evidence of artificial origin. He noted that comets are like cats. They have tails, and they do precisely what they want, meaning that unusual behaviour should not surprise us. Wright's analysis is thoughtful and deserves serious consideration. He points out that our sample of interstellar objects is too small to establish firm expectations. He notes that planetary scientists have observed bizarre behaviour from solar system comets for decades. He argues that the anomalies, while genuine, do not require technological explanations. But Wright's critique also has limitations. He has not provided alternative calculations, showing that the combined probability of observed anomalies is actually higher than Loeb claims. He has not explained the specific mechanism by which natural processes produce the observed 8-degree rotational alignment. He has asserted that the anomalies are expected without demonstrating that expectation quantitatively. NASA's position, articulated at the November 19th press conference, has been similarly dismissive. Associate Administrator Amit Kshatriya explicitly stated that 3i Atlas is not related to extraterrestrial life, a conclusion presented to reassure the public rather than to engage with scientific uncertainty. I understand the institutional pressures at work here. NASA receives public funding and operates under political constraints. Suggesting that an interstellar object might be artificial would generate enormous media attention, congressional scrutiny, and public anxiety. The safer path is to declare the object natural and hope the question fades from public consciousness. But science should not be about institutional safety. It should be about truth. The fundamental disagreement between Loeb and his critics comes down to burden of proof. Critics argue that extraordinary claims require extraordinary evidence, and that the artificial hypothesis is extraordinary enough to require definitive proof before being taken seriously. Loeb argues that the evidence we have is already extraordinary enough to warrant serious investigation, and that dismissing the artificial hypothesis without rigorous analysis is itself unscientific. Both positions have merit. We should not leap to extraterrestrial conclusions based on ambiguous data, but we also should not exclude extraterrestrial hypotheses simply because they make us uncomfortable. The history of science is filled with examples of mainstream resistance to paradigm-shifting ideas. Continental drift was ridiculed for decades before plate tectonics became accepted. The bacterial cause of ulcers was dismissed by medical authorities until Barry Marshall infected himself to prove the point. Prions, proteins that can cause disease without nucleic acids, were considered impossible until Stanley Prusiner demonstrated their existence. In each case, established experts were confident in their positions. In each case, they were wrong. The anomalies they dismissed turned out to be clues pointing toward revolutionary discoveries. I am not claiming that 3I Atlas will follow this pattern. It may well be a comet, unusual but natural, a fascinating scientific object that teaches us about interstellar chemistry without overturning our understanding of life in the universe. But I am claiming that we do not know yet. The data is still being collected. The analysis is still underway. The definitive answer has not been established. And in that state of uncertainty, closing off lines of inquiry based on professional consensus rather than evidence is a betrayal of the scientific method. Loeb has called for continued observation and analysis. He has urged spectroscopic measurements of the jets to determine whether they stem from ice sublimation or technological propulsion. He has requested high-resolution imaging to search for structural features that might distinguish natural from artificial origin. He has advocated for open-minded investigation that follows evidence rather than assumption. His critics have largely responded with assertions rather than engagement. They have declared 3I Atlas natural without explaining away the anomalies that suggest otherwise. They have invoked authority and consensus where evidence and analysis are required. The math is screaming. 1 in 4 billion, 15 anomalies and counting, precision alignments that defy random chance, thermal behaviour that contradicts known cometary physics, a trajectory engineered to arrive at Jupiter's gravitational boundary. Someone should be listening. Instead, the scientific establishment has largely turned away, satisfied with declarations of normalcy that the data does not support. The public is told not to worry, that this is just a comet, that there is nothing unusual happening in our cosmic neighbourhood. And 3I Atlas continues on its trajectory, carrying whatever secrets it holds past Earth, past Jupiter, and eventually back into the interstellar void, where no human instrument will ever observe it again. If we are wrong about this object, we will never know. The opportunity to discover the truth is closing, and those with the power to investigate are choosing not to. That is the real anomaly. Not the object itself, but our response to it. What happens after December 19th, when the world stops watching? The headlines will fade. The social media posts will slow. The breathless speculation will give way to the next news cycle, the next crisis, the next viral distraction. 3I Atlas will continue outward through the solar system, growing fainter by the day, and the world will largely stop watching, but the object will still be there. In the weeks following perigee, 3I Atlas will cross the space between Earth's orbit and Mars, heading for its March encounter with Jupiter. Ground-based telescopes will continue tracking it, though the observations will become more challenging as the apparent brightness fades. By January, only large professional instruments will be able to resolve meaningful detail. By February, the comet will be a dim smudge requiring hours of exposure time to detect. The International Asteroid Warning Network's coordinated observation campaign ends on January 27, 2026. After that date, systematic monitoring will give way to sporadic observations by dedicated researchers. The flood of data will become a trickle, and eventually, silence. This is the nature of transient phenomena. They arrive, capture attention, and depart. The universe does not pause to accommodate human curiosity. 3i Atlas spent billions of years travelling to reach us, and will spend billions more travelling away. Our window of observation measures in months, a cosmic blink that has somehow become the most intensive study of any interstellar object in history. What have we learned? We have learned that 3i Atlas is compositionally distinct from solar system comets, with unusual ratios of nickel to iron, extreme abundances of hydrogen cyanide relative to other species, and progressive release of carbon dioxide, methanol, and now diatomic carbon. We have learned that its anti-tail persists through perihelion in ways that challenge conventional models of cometary activity. We have learned that its thermal behaviour suggests internal structure unlike any comet we have studied before. We have learned that its trajectory shows precision alignments with the ecliptic plane, with the sunward direction, with Jupiter's Hill radius, that are statistically improbable for a random object. We have learned that its arrival timing minimised observation during the most dynamic phase of its solar encounter. We have learned that its rotation axis orientation produces jet behaviour more consistent with directed thrust than chaotic sublimation. And we have learned that the scientific community is deeply divided about what all of this means. Some researchers, led by Evie Loeb at Harvard, argue that the accumulation of anomalies demands serious consideration of the artificial hypothesis. Others, including prominent voices like Brian Cox and NASA officials, insist that 3i Atlas is simply an unusual comet, and that extraterrestrial speculation is unfounded. The debate has played out in scientific journals, blog posts, podcasts, and press conferences without resolution. After December 19th, this debate will continue, but with diminishing intensity. The dataset will be fixed, no longer growing with each new observation. Researchers will analyse and reanalyse the available information, publishing papers that support one interpretation or another. Consensus may eventually emerge, or the question may remain open, a permanent asterisk in the history of astronomy. The Jupiter encounter in March offers one more opportunity for dramatic revelation. If 3i Atlas releases objects as it passes through Jupiter's Hill sphere, the discovery would rewrite everything we think we know about our place in the universe. If it passes silently, as most expect, the encounter will simply refine our understanding of its trajectory and composition. The Juno spacecraft will be watching. The data it collects may take months to analyse. By the time any conclusions are published, 3i Atlas will have faded beyond easy observation, a memory embedded in archives rather than a presence in our skies. What happens then? The analysis will continue for years, perhaps decades. Graduate students not yet born will write dissertations on the spectroscopic signatures of 3i Atlas. Theorists will develop models attempting to explain its anomalies through natural processes. Some will succeed, identifying mechanisms we had not previously considered. Others will fail, leaving the anomalies unexplained, and always in the background will linger the question we could not answer. What was it really? If 3i Atlas is artificial, we may never know. It will not return in human lifetimes. It will not send messages we can detect. It will simply continue outward, carrying whatever purpose it serves into the darkness between stars, leaving us with observations we cannot fully interpret and questions we cannot definitively resolve. If it is natural, we will have learned something profound about the diversity of objects in interstellar space. We will have discovered that comets from other solar systems can behave in ways radically different from our own. We will have expanded our understanding of the processes that shape material across cosmic distances and timescales. Either answer is valuable. Either answer advances human knowledge. The tragedy would be not in being wrong about the object's nature, but in failing to pursue the question with appropriate rigour. There is a kind of poetry in watching something pass beyond reach. We have spent these months straining every instrument toward a visitor from another star, gathering photons that travelled for billions of years to reach us. In return, we have offered nothing but observation, the attention of a species just beginning to look outward from its small world. 3i Atlas does not know we are watching. If it is natural, it cannot know anything at all, just ice and rock and dust, assembling and disassembling, following the laws of physics without awareness or purpose. If it is artificial, its designers may have known we would watch, may have anticipated this moment when a young civilization would turn its primitive instruments toward their creation and wonder. Either way, the watching has value. It is what we do, the thing that makes us human. The impulse that built telescopes and launched spacecraft and sent our own probes into the interstellar medium. We look because we must. We ask because we cannot stop ourselves. We reach toward the unknown because the alternative, accepting ignorance without struggle, is intolerable. December the 19th, 2025 will be remembered. Perhaps as the day an interstellar comet passed closest to Earth, a footnote in astronomical history. Perhaps as the day something far stranger brushed past our world while we struggle to understand it. The significance of the moment depends on truths we have not yet uncovered. For now, we watch, we record, we wonder, and tomorrow, 3i Atlas begins its long goodbye. Thank you for joining me on this journey through one of the most remarkable events in modern astronomy. Whether you believe 3i Atlas is a natural comet or something more, I hope, this exploration has given you new perspective on the mysteries that surround us. If you found value in tonight's documentary, please take a moment to like this video and subscribe to the channel. Your support makes it possible to continue bringing you deep investigations into the phenomena that mainstream science often overlooks. And if you have thoughts about what 3i Atlas might be, share them in the comments. I read every one, and your insights often inspire future explorations. As always, remember that the views presented here represent one interpretation of the available evidence. Science is an ongoing process, and today's mysteries may become tomorrow's discoveries. I encourage you to think critically, examine the data yourself, and form your own conclusions. The universe is vast beyond comprehension, filled with wonders we have only begun to glimpse. 3i Atlas is one such wonder, a visitor from the darkness that has reminded us how little we know and how much remains to be discovered. Wherever you are watching from tonight, whatever time it is in your corner of this small planet, I wish you clear skies and restless curiosity. Good night, and keep looking up.